Hello, everybody. Today we are starting our video series on solving problems using linear systems. So we will be doing word problems for the foreseeable future. There are a lot of different types of word problems that can be modeled with linear systems. So we'll be moving through type by type so that you kind of learn how to do each type. Okay, the only way to really get good at these is to practice, and more practice. So let's just remember that we know a lot of different ways to solve a linear system of equations. So graphically by hand, graphically by technology, algebraically by substitution, and algebraically by elimination. So now we can apply these methods to more challenging problems. Remember to always identify two variables using specific information and units. So our first type of question is number and age questions. So I'll be doing two examples, which are representative of the type of questions you will get. So Christian has a total of 8 cars and trucks to play with. His birthday is soon. He hopes to double the number of cars he has now. If he does, he will have a total of 11 cars and trucks. How many cars does he have now? How many trucks? So notice that the question is asking how many? How many? So that should give you an indication of what your variables should be. The number of cars he has, the number of trucks he has. So we'll say, let's see, represent, oops, no idea why that happened. Let's see, represent the number of cars he has now. And let T represent the number of trucks he has now. All right, so right now he has a total of 8 cars and trucks. So his cars plus his trucks will equal 8. By the way, just a little communication tip. If you use a lowercase t as a variable, make sure to put a little tail on it so that it looks different than the plus sign. Then it says if he doubles the number of cars he has now, so 2 cars instead of just cars, he'll have a total of 11. So his 2 double cars plus the trucks will then equal 11. So how many cars and trucks does he have now? So taking a look at this is pretty naturally set up for elimination rather than substitution. Again, you can use substitution, that's absolutely no problem. But notice if we just subtract the 2 equations, we can solve it. So if I had more space there, I would have just done it right there, but I'll just rewrite them. Okay, I'll put the 2c plus t equals 11 on top, and then the c plus t equals 8 on the bottom. And we can subtract the 2 equations. Okay, so 2c minus c is just c. T minus t goes away, that's what we wanted. 11 minus 8 is 3. So c equals 3. That means the number of cars he has is 3. Therefore, trucks has to be equal to 5. This is pretty low numbers, so you can just eyeball that and see that 3 plus 5 is 8. So then you write a sentence. Therefore, Christian has, okay, and you can finish that up, 3 trucks and 5 cars. Sorry, 3 cars and 5 trucks. So go back to the sentence and make sure that you're answering specifically what is being asked. Okay, so now we go into a little bit more complicated of an age problem. I want you to really pay attention to this example because it has a tricky little thing in it that's hard to understand for most students. So really pay attention to this example particularly. So John is 3 times older than his dog. 4 years ago, he was 7 times older. How old is John's dog? So the 2 things that we don't know are John's age and his dog's age. So we'll say let J represent John's current age, okay? It's important that we say current age because we have now and we have 4 years ago. Okay, and it's in years. And we can say let D represent the dog's current age in years. Not dog years, years. Okay, so what I would like you to do now is to pause the video and try to make this system of equations. So to try to create two equations. I'll give you a hint. One equation is going to be from this sentence, and the other equation will be from this sentence. So go ahead and try to do that because most students make a mistake. And in this case, I kind of want you to make a mistake because I want you to see where that is to hopefully avoid it in the future. Okay, so hopefully you tried it. I'm going to go ahead and show you what to do. So John is, so when we see is, we typically think of an equal sign. John is 3 times older than his dog. Okay, so if John was 12 and his dog was 4, this equation would work. I kind of just do that kind of stuff in my head to make sure that my equation makes sense. So if the dog was 4, then John would be 3 times 4 is 12. He's older. That's good. Now, it's the 4 years ago one that's tricky because 4 years ago, how old was John? Well, John is currently J, so 4 years ago, he was J minus 4. So 4 years ago, he was 7 times older than the dog. Now, don't write this down. What I usually see is this or maybe this. This is not correct. What this equation does is it takes the dog's age times 7 and then subtracts 4. We need to add something. We need to add brackets. This takes the dog's age 4 years ago and then multiplies it by 7. Bad math tells you to find his age 4 years ago and multiply it by 7 before you do the multiplication. This is a crucial step, which allows you to then use the the distributive property. So these are your two equations. This is equation 1 and this is equation 2. Now, here substitution is best because this is already isolated for J, so you can sub that 3D in for J in equation 2. So you get 3D minus 4 equals, now let's use the distributive property, 7D minus 28. So 3D minus 7D equals negative 28 plus 4. So you get negative 4D equals negative 24, or D equals 6. That means the dog is 6 years old. Therefore, we can find out John's age, which is just 3 times that. So John is 18. Okay, so let's double check that this makes sense. So right now, John is 3 times the dog's age. That makes sense. 18 is 3 times 6. 4 years ago, John would have been 14 and the dog would have been 2. 14 is 7 times 2, so that works. Always do a quick mental check to make sure that you're actually, your solution actually makes sense within the context. So the question asked, how old is John's dog? We can answer John's dog is 6 years old. All right, so that's a typical kind of age question. All right, this one involves money and a measurement. Okay, so Mr. Shuttleworth cleaned out the pop machine and found $3.10 made up of dimes and quarters, and there were 19 coins in all. How many dimes does Mr. Shuttleworth have? So notice it asks for how many of a coin. We already know that dimes are worth 5 cents and quarters are worth 25 cents. So it's how much, not how much money they have, but actually how many of each coin. So we'll say let D represent number of dimes and let Q represent number of quarters. Okay, so that is step 1, identifying our variables. Now we have to come up with 2 equations and 2 unknowns, with our 2 unknowns. Notice we have 2 totals. We have a total of 310, which is money, and we have a total of 19, which is number of coins. So if this is number of coins, then what it's made up of, what we're adding together, should be the number of each type of coin. Well, D, we said, just represents the number of dimes, and Q just represents the number of quarters. So the number of dimes plus the number of quarters equals the total number of coins. However, here this represents money. So this is how much money we have. So we have to think of how much money do we have in dimes and how much money do we have in quarters. So if we have dimes, each dime is worth 5 cents. So we have 5 cents times the number of dimes and 25 cents times the number of quarters. So this is, and you can write it in here if you want, I don't really have room. So this is how much money in dimes and how much money in quarters equals total money. And then number of dimes and number of quarters equals number of coins. So make sure that what you're adding together matches what you should be equal to. Okay, so now we have a system, a linear system, which can be used. You can do either substitution or elimination. Okay, both of them are good options here. I don't really overly recommend one or the other. It's whatever you're comfortable with. If you want, you can pause the video and try to find the solution yourself. You will get 11 dimes and 8 quarters, but I will go ahead and show you one method of solving this. I used elimination. So if this is equation 1 and this is equation 2, the first thing I did was multiply equation 1 by 100 to get rid of the annoying decimals. So I got 5d plus 25q equals 310. Okay, that was equation 1. I multiplied it by 100. And then the second equation, this whole time I've been saying dimes are worth 5 cents. Dimes are not worth 5 cents. Dimes are worth 10 cents. Mrs. Weens made a mistake. You guys have probably been wondering, like, what kind of dimes does Mrs. Weens use? Because she's been not getting enough money. There we go. Okay, change that little mistake. Hopefully you're all good. Okay, there we go. Dimes are 10 cents. All right, so to get a similar coefficient down here, I'm going to multiply this all by negative 10. Okay, so I get negative 10d minus 10q equals minus 190. And I'm going to add these two equations together. So I get 15q equals 120. So if I divide 120 by 15, I get q is equal to 8. Okay, so if I go back and put that in here, I can see that dimes is equal to 11. So therefore, Mr. Shuttleworth has 11 dimes. Okay, again, if you prefer substitution, works very well. So that is a money and measurement question. For today's video, we're going to do one more problem, which is investment and banking. So in these questions, usually somebody has invested money into 2 different accounts that earn 2 different amounts of interest. And you want to see how much they put in each account. This is a typical investment and banking problem. So in this case, we have Mr. Fittler invested $1,500, part at 5% and the rest at 7% per annum. Okay, per annum is just a fancy way of saying per year. So that means that this money, $1,500, makes 5% per year of interest. Or sorry, not $1,500, however much they put in. So after 1 year, the interest earned on the 7% investment was $45 more than the interest on the 5% investment. So how much did he invest at each rate? So how much did he invest at each rate? So the question should tell you what your variable should be. We want to know how much money he invested at each rate. So that's what our variable should be. So we'll just say let X represent dollars invested at 5% and let Y represent the amount invested at 7%. Now I'm going to do something that is a very good strategy while you're still learning these. I'm going to make 2 English sentences and make them into the math sentences because this can be a little confusing. So he invested a total of $1,500. So that means that the amount in the 5% plus the amount in the 7% equals $1,500. Okay, that's what that means. The amount he put in 5% and the amount he put in 7% equals 1,500 because that's how much he did total. Now, after 1 year, the interest earned on the 7%. So the interest on 7% was, so that's an equal sign, $45 more than the interest on the 5%. So it's the interest on the 5% plus $45. Okay, writing these English sentences can really help you guys keep a clear head so that you're not putting in the variables right away, which can feel really complicated. So we just let X represent how much he invested at 5%. So this is just X, and this is just Y. So this first equation is X plus Y equals 1,500. That's our first equation. Okay, but how do we figure out the interest on the 7%? Well, the 7%, he put Y dollars in at 7%, and it earns 7%. So he gets 7% times Y. That's the interest that he gets off of that. 7% of whatever he invested at that rate. So that equals, now, how much did he earn off the 5%? Well, he earned 5% of whatever he invested, which is represented by X. And then we do plus 45. Okay, so be careful when you're doing 7 and 5% to put the extra 0 there. 0.7 would be 70%, which would be quite the nice interest, but doesn't actually work. Okay, so here are your two equations. All right, so here's equation 1, and here's equation 2. So again, you can use either, oh, that looks awful. I'm just going to take that away. So you can use either algebraic method. What I would recommend is substitution in this case. So I would rearrange this for X or Y, but I rearranged it for X is equal to 1,500 minus Y. And then I sub that into this equation. So you get 0.07 Y equals 0.05 bracket 1,500 minus Y bracket plus 45. So then I get 0.07 Y equals, now 5% of 1,500, that's 75. So you get 75 minus 0.05 Y plus 45. Then you add 0.05 Y to both sides. So you get 0.12 Y equals, and then 75 plus 45 is 120. And then you divide both sides by 0.12, and you get Y is equal to 1,000. So that means he invested $1,000 at 7%. And because it added to 1,500, we can see relatively easily that X would be 500. So then you would put a nice little therefore sentence. Mr. Fittler invested $1,000 at 7% and $500 at 5%. So it's very important for these questions that you understand the difference between the money that was invested and the interest that was earned. Okay, so the interest earned, you have to multiply it by that decimal. All right, so those are your first 3 different types of problems: number and age, money and measurement, and investment and banking. Okay, so let's really work on perfecting these types of equations, these types of problem solving, so that we can move on to some more difficult ones. Thanks for watching. I hope you learned lots.